Stratospheric ozone depletion. Number one. Okay, I think we filled these in the other day, but I'm going to go back over them because I'm sure all of y'all forgot everything you remembered from before spring break. The stratospheric ozone layer is important to the evolution of life on Earth and the continued health and survival of life on Earth. So we talked about some of the issues related to stratospheric ozone. Now let's go back real quick. The layer of the atmosphere closest to the Earth is the troposphere. Good. Tropospheric ozone is bad because tropospheric ozone causes respiratory issues. It's a byproduct primarily of
CFCs?
photochemical smog. Good. Now, stratospheric ozone is good. So stratosphere, remember you got troposphere and then the stratosphere is above that. Stratospheric ozone is good, Jeremiah, because it helps
block the UV rays.
block what?
The UV rays.
Which ones? Do you remember?
No.
If you'll turn to 425 in your book there, I don't know if I went through this. I'm going to go through it again. So UVA rays pass through the atmosphere without being absorbed. So UVA is coming straight through. Now, when you guys come up with this experiment later on that we're going to conduct later in the week, I've got UVA sensors and I've got UVB sensors. So we're going to test these two. I don't have UVC sensors, but UVB and UVC, both of those are primarily, it says 99%, are getting absorbed by the stratospheric ozone. Okay? So now there's a little bit coming through, but 99% is getting absorbed. UVA, most of that's coming through. So you guys are going to come up with an experiment to test some type of variable to see how different things affect UV radiation and exposure.
Wait, which one makes you tan?
Which one makes you tan? Well, if you'll notice there in the middle of the left side of 425, it says UVA passes through the atmosphere without being absorbed and contributes to and possibly initiates skin cancer. UVB and UVC potentially cause significant damage to tissues and DNA of living organisms. So I would suspect, tanning is basically your skin getting, some of the cells getting burned, and the tanning response is your body's way of amping up the melanin production. So as long as you have melanocytes, as long as you're not albino, you have some melanin. Some of us have more melanocytes than others. And so the more sun exposure, then the higher the rate and the bigger the tanning response. But all of these are going to cause some damage to skin, just depending on how well adapted you are is going to determine the effect. Now, tanning bed, that's a good question. So tanning bed's not used as much nowadays as they were when I was growing up. Like people used to hang out in the tanning bed all the time when I was growing up, and even probably 10 years ago. And so I think they say tanning beds, like the UVB rays are like 5 times worse than the sun. Like even like a hot midsummer day on the beach, like 5 times worse than that. So those UV rays are bad. I tell you about the girl who had melanoma, didn't I? So there was a student, there was a girl who used to go here. I think she graduated right about either the year before or after when I started in 03. And so I think it was 03. And so she's like a Facebook friend of mine, but I think she lives over in the north side of town now. Anyway, her dad died from melanoma a few years ago. And so she's been like extra vigilant about vigilant about checking for spots and stuff. We talked about the ABCD rule for checking for stuff. Did anybody check out their grandparents this week off? You got to check those old people. They don't know what to look for. Anyway, so just be like, text your grandma or grandpa, hey, can you send me some pictures of your head, shoulders, and back, and just let me check those out for you?
There's going to be so many questions I got to answer.
I just see grandma writing back, question mark. And you writing back sun emoji. There we go. So anyway,
Do you mind taking it for me?
do what?
My grandma will be like, do you mind taking it for me?
Okay. That's too much. Where was I going with this? Melanoma. Oh, yeah. The girl. So her dad died a few years ago of melanoma, and so she found a spot. They went in and checked it. They thought it was cancerous. They thought it was melanoma. Turns out it was melanoma, and so they went in and cut it out. And so she was happy. A couple days later, they said they got clean margins, which basically meant they were able to come in and cut everything out, and there was they were able to cut all the way out around it, and it hadn't spread anywhere else. And so that was good. So it's just one of those things that you have to look out for. And like we,
Go to the tanning bed?
I think she probably did growing up, but she also, I know they've got a pool, so I'm sure they hang out in the sun all the time. And, a lot of people like the tanning response. So, some people, what's that, like the tanner, that's like basically lathering on like baby oil almost when you go to the beach. It'll like fry you to a crisp if you're not careful. Suntan, yeah, it's not even like, I don't think it's blocking out anything. I think it's just burning you. You know what I'm talking about?
Palm tree on it.
Yeah. Anyway,
Aloe vera.
a lot of people try to evoke as much of a tanning response as they can. Anyway, so that can be a problem as you get later on in life. One, skin cancer is an issue, and then the other one, you'll have to look this up, Sophie, or somebody else wants extra credit. Some of these UV rays, skin cancer is not only the issue. A lot of it has to do with like aging of the skin. So you'll see like older women. I feel like this is always see this on older like white women who look like they hung out at the beach too long. That looks like their chest is like made of leather, and it's all wrinkly. And so, but like basically what happens is like a lot of that UV radiation will break down your collagen and other like elastic fibers. And so once that breaks down underneath the skin, like it gives you that, a lot of wrinkles result, and it gives you that kind of leathery appearance. So that's why I would suggest, if you want to look youthful and young, the longer you can, try to avoid as much sun exposure as you can. So, and typically it's worse if you'll notice like older people, typically the fairer the skin, the more you see those wrinkles, and the older they get quicker, just because UV radiation is going to have a bigger effect. Anyway, something to think about as you get old. You're not young forever, trust me. So, number 2, stratospheric ozone depletion is caused by anthropogenic factors such as chlorofluorocarbons or CFCs. So, really the bad part of the chlorofluorocarbon is the what? Which part? You've got chlorine, you've got fluorine, and you've got carbon. You might know?
Carbon.
Nope.
Chlorine.
They're going to show this in the video today. If you look at the bottom, Layla, on page 425 there, they've got the equation for this. Sometimes that chlorine will break off, and once it breaks off and interacts with ozone, then it breaks the ozone down into just regular O2. And so that's the problem. And kind of keep recycling and doing that over and over again. So something to look out for. And also natural factors such as melting of ice crystals in the atmosphere at the beginning of the Antarctic spring. So we talked about early spring in Antarctica, or even the Arctic. We're going to watch a video, and basically it says there's not really a hole in the ozone. There's just like dramatic thinning. And so, but it's significant in the amount that it's thin. There's still a little bit of ozone there, but it's not much. And so basically what happens is, this is kind of the third grade version that I can explain because I don't understand it better than this. But basically in like Antarctica, in the wintertime, you have these clouds that form way up in the stratosphere, and there's the clouds, there's moisture, and then there's these ice crystals. And for some reason, that moisture and those ice crystals cause the chlorine and the ozone to react with one another and break down. And so once you get out past like late spring and into Antarctic summer, once it heats up a little bit, those clouds kind of dissipate. You know how like sometimes we'll have clouds in the morning and then it heats up and the clouds kind of go away. So, and then like essentially what happens later on is that thinning, like more ozone will come in and fill in, and the thin layer, or what a lot of people call the hole in the ozone, kind of fills back in because these air currents are circulating ozone all around the earth. Okay? And if you think about it, where did the CFCs come from that caused the hole? Did they come from Antarctica? Yeah, so they're primarily coming from industrial countries in the northern hemisphere, like the U.S., Canada, Europe, probably some Southeast Asian countries. And this is all prior to 1987, okay, and even a little bit past that. So we got confused this morning because they said they stopped, or they signed the Montreal Protocol or they said something about it in 1989. It was signed in 1987, and I think it actually went into effect in 89. Why do you think it didn't? They just didn't say like we're going to stop all CFCs in '87.
Because the companies
They
needed
didn't
time to
figure
start
out
production.
what else.
Yeah, I mean, like if you're Rachel, if you're running a refrigerator company and you're using CFCs as your refrigerant, well, CFCs are bad, but people also need refrigerators to keep food cool. So you've got to find some other substitute that you can fill in and use for the CFCs. So it took a couple years to kind of get things switched over. Some places obviously longer than others. Okay. Number 3. A decrease in stratospheric ozone increases UVs that reach the Earth. Exposure to UV rays can lead to skin cancer and cataracts in humans. I don't know why the AP classroom says cataracts in humans. I mean, like, a lot of animals can get cataracts. I mean, I've seen cats have cataracts and dogs have cataracts and other animals I'm sure can too. I guess they're just being egocentric humans like we all typically are. But cataracts is another kind of byproduct of UV exposure. All right, and did we do number 4? No. Okay, let's go ahead and go over number 4 real quick because it's going to mention that. Number 4, let's turn over to 521. So in your book on 521, there's a chart. I'll show you for the friends out there. So this chart, which one of the ozone molecules is, or which one of the greenhouse gases is the most highly concentrated? Carbon dioxide. If you look at parts per million, carbon dioxide's at 390. Chlorofluorocarbons down there are like at 0.9. And then water varies quite a bit depending on if you're in like the desert or if you're like in the rainforest, right? Now, I would say this. Water is probably our number 1 greenhouse gas. In terms of holding heat in the earth, water is probably your number 1 thing. But that's something that varies, something that we can't really control. We can control CO2 production somewhat, and we can control methane production and nitrous oxide production, and then also chlorofluorocarbons. Now, pound for pound, which one of these is worse? CFCs. Like, it's a really bad greenhouse gas. Now, we've stopped production, like we said, so that shouldn't be a big contributor going forward. But in terms of just pound for pound, it is. And then one that they don't list on there that's a new problem is number 4 in your notes. Ozone depletion can be mitigated or offset by replacing ozone-depleting chemicals with substitutes that do not deplete the ozone layer. Okay? So replace your CFCs with something that doesn't hurt the ozone layer. The problem is they started using hfcs. Now, hfcs don't deplete the ozone layer because they don't have chlorine. But they are a strong greenhouse gas. So they've still caused the issue related to greenhouse gases. Greenhouse gases don't contribute to the depletion of the ozone, but they do contribute to what? What? Global warming, yes. So the last thing I want to talk about today is making sure you understand the difference between these 2 topics, because this is something that gets confused a lot. So you might want to make a little chart like where you divide it and put 2 things, one on each side. Something so that you can distinguish here. So depletion of the ozone on one side and global warming or climate change on the other. I'm just going to say warming since we're talking about heating up the earth. Okay, so depletion of ozone. Colby, you getting all this? And global warming on the other. A lot of people get these 2 topics. They think they're similar and similar causes and similar effects. They are not. There is one thing that's an overlap between the 2, and we'll talk about that, but they're really 2 different subjects. Okay? DeQuinte, what causes the hole in the ozone or thinning the ozone?
Factory emissions.
Well, of what specifically? Caleb? God bless America. We just went over this. Jordan? CFCs. So, CFCs cause thinning in the ozone layer, which allows more UV radiation, UVB, B and C specifically, to get through. UVB and UVC is bad for what? Tissues, yeah, like tissue damage, DNA damage. Okay, this isn't really like a warming effect. Okay? So it's bad because of how it affects organisms on Earth, like their tissues and DNA and stuff. Now, global warming, different topic, okay? So global warming is primarily caused by excess greenhouse gases, which cause an increase in the temperature on Earth, okay? Because those gases act like a blanket around the Earth, and they help to hold in more heat, which helps to heat up the Earth. Andrew, you getting all this? Don't fall asleep. So, the only overlap between these two things is what? Well, they are both harmful. What else?
Like where they come from.
One thing, yeah, one of them where they come from. So we said CFCs cause the breakdown of ozone molecules.
CFC is a greenhouse gas.
CFCs are also a bad greenhouse gas. Okay. So, that's really, the CFCs are causing a depletion of the ozone, and CFCs can also contribute to global warming. But the hole in the ozone isn't making the Earth warmer. That's the one distinction I want you to make there. Okay? So it's not a big contributor to the heating of the Earth. So make sure you make that distinction. All right, any questions? So for those of you at home that are in my class at HCHS, you are going to conduct an experiment. But you have to come up with your experiment. Now, unfortunately for you, you don't have the lab equipment at home. But I do still want you to come up with an experiment that is testable. And when we test this, probably Friday, I think is the next sunny day, we will video and we will share these with you guys so that you can see some of our tests on UV radiation and exposure. Okay?